If light is just a disturbance moving through some medium, why does it travel in clean, sharp beams instead of smearing out equally in every direction? In the energy filament theory, the direction of light is not chosen halfway through space. It is pre-selected by tiny spin patterns wrapped around the particles that emit it. Those patterns leave only certain doors open for the disturbance to escape. Textbooks trained us to picture a disturbance using water as the default image. Drop a stone in a calm lake and circular ripples spread out evenly, ring after ring, with no preferred direction at all. So if light is also a disturbance, it feels natural to ask why it does not behave like that simple pond picture. We still have to explain why a flashlight or a laser can pick one path and stick to it instead of fading into a flat glow. In this picture, the starting point is different. The universe is filled everywhere with a tense energy sea. Every solid thing you know is a bundle of that sea twisted into loops and filaments that have to stay locked in a stable shape. Around each such loop there is a tiny near field, a closed-up texture you never see directly. You can imagine it as a pattern of grooves and ridges carved into the sea around the particles, like the teeth of a gear or the threads on a screw. These spin patterns have a specific orientation and structure, and they act like a three-dimensional socket that holds the whole particle together. In some directions the socket clamps down hard, so motion is tightly locked and nothing extra can get out. In other directions it is looser, more like a channel than a clamp, and there it is easier for motion to leak away. Now picture an electron in an excited state carrying a little to much energy. When it drops to a lower state, it has to give that excess energy back to the energy sea. The electron does not open a menu and chooses left, right, or straight ahead. It simply shudders along the spinning pattern it already has. And the only directions that allow the disturbance to escape are the ones where the pattern has its built-in channels. It is like pressure in a tank of water that has just a few pipes welded into the wall. When you overpressurize the tank, the water does not have a decision to make. It rushes out through the existing pipes and nowhere else. In the same way, the extra energy in the particle leaves through the pipes, cutting into its spinning texture. Those pipes define the directions of the outgoing light before the light even exists. Once the disturbance is out in the wider energy sea, it keeps moving along the path it was launched on. The sea is smooth on larger scales and no longer has those gears like teeth to redirect it. That is why light from a single emission event does not instantly spread out into a perfect shell the way a textbook drawing of a point explosion might suggest. At the same time, if you add up many such events with many different spin orientations, you can still get the familiar light in all directions picture for a star or a glowing lamp. A star is not one perfect nozzle. It is an enormous crowd of particles, each with its own tiny spinning textures pointing some way in three-dimensional space. Every time one of them gives up energy, it spits out a disturbance along its allowed channels. From far away, all these narrow escapes overlap and blur into something that looks almost round, even though at the microscopic level each emission event is sharply guided. This view also hints at why the internal structure of matter matters so much for where light goes. Change the orientation of those spin patterns and you change which escape routes are available. That is part of why crystals can send light only at specific angles and antennas do not radiate equally into every patch of the sky. The near-field shapes act like sculpted launch pads for the energy sea. Direction is not an afterthought that light picks up as it travels. It is a choice baked into the fine structure of the emitter, encoded in the tiny swirl-like patterns that decide where motion is locked and where it is allowed to run free. Once you accept that, the question shifts from why light has direction at all to what these deeper patterns look like and how they control the beams we see. The next step is to ask how a disturbance that starts in one tiny channel can stay coherent and readable after crossing ridiculous cosmic distances without dissolving into noise. It is also to ask how much of the universe's history is hidden in the exact way those beams arrived. Tap follow, share it on New Physics, Clear Universe.